All right, so today we are working with equations with fractions in them. They may be numerical fractions, they may be rational fractions, we may have variables in numerators and denominators. Radical equations, so we're working with square roots in equations, and we're working with systems with 3 equations, 3 variables. So first, here is one rational equation. And I don't really like doing equations that have fractions in them. This one is an equation, not an expression. So how can I just get rid of having fractions? How can I get rid of all of those denominators? Does anybody remember what we need to do? What are we going to have to do there?
We multiply the full equation by the denominators.
Which means, what do I multiply by here? So I'm going to multiply by the least common denominator, which is, for this problem specifically, what's my least common denominator going to be? Is it Jimmy?
15 parentheses, full line 3 parentheses, 3 parentheses, 5 parentheses, x plus 7.
Or 15 times x plus 7, whichever way you want to think about it, whichever way is easier for you to write that. Then we're going to multiply each term by that. So when I take 15x plus 7 times the first term, the 15 will cancel out the denominator. 15 over 5 will be 3. I will still have the x plus 7, and I will still need to multiply that by this numerator 2. When I multiply the second term, the x plus 7 will cancel, and I will have the 15, which needs to be multiplied by the numerator. And when I multiply by the final term, the 15 over 3 will cancel, and I will have 5. The x plus 7 will not cancel, and that will still need to be multiplied by the numerator. So you guys finish it for me. And I'll attempt to catch up. Let's see, that's a 6. So 6x plus 42 plus 60. That's a 20 to distribute. So 20x plus 140. And most of you have stopped writing, so everybody, what have you gotten? Negative 19 over 7 is what I'm hearing. Let's see if I can catch up and also get that. So let's see, if I subtract my 20x on both sides, I have negative 14x. And if I subtract 102 on both sides, I have 38. Divide both sides by negative 14, and I got the same thing that you did, reduce negative 19 over 7. So good job. Anybody with questions on that one? Okay, then here's our next one for today. This is a system, not the 3 by 3s yet. This is just two equations, the 2 variables x and y, but it looks so messy. Got fractions in one and decimals in another, so they're both rational equations. What can I do to clean this up and maybe make it a little bit easier to work with? I need some help. I need some ideas. What can we do? Emma?
You can get rid of the denominators of fractions and also big.
How do I do that?
Well, you multiply the entire equation by 10.
Okay, so we'll multiply that one by 10, and you started to say, and also... And what do I do there?
To move the decimal to places that would multiply by 100.
Exactly. So we've got 2 decimals here, 1 for the y term and 2 decimals for the constant. The most is 2, so if we multiply by 100, we move those decimals 2 places and get rid of all of those. So let's see, that gives us 5x plus 6y equals -4. And you guys check me. Don't let me make an arithmetic mistake as I get those up here. Let's make sure we get the right equations as we go along. And then if I move this 2 places multiplying by 100, I have 6x. Need a placeholder there so I can move it twice, minus 20y. And move this one twice, and I have 104. So does that look like I have those 2 correct? Okay, so yes, that got rid of my fractions and decimals, but now what in the world am I going to do?
Elimination and substitution.
So how am I going to do that? Help me out here. Specifically, what do you want to do? Okay, so if I do elimination, how do I do that? So I need to multiply. Somebody who can help me out. What do I multiply by what? What's your idea?
We multiply the top x by 6.
Okay, so we look at these. We want either the x coefficients or the y coefficients to have the same value but be opposites. So one positive, one negative. 6 and 20, yeah, I could get those, but that's going to give me bigger, messier numbers to work with. Easiest if I get these both to be 30x, but one positive, one negative, so I can multiply the top by 6, the bottom by 5. One of them needs to be negative, does not really matter which. I don't remember which one you said, so I'll just do the top one with the negative. That is going to then give me negative 30x minus 36y equals positive 24, and positive 30x minus 100y equals something big, 520? Did I get those correct? So then the x's cancel out. Negative 136y equals 544. Divide both sides. I'm going to need help here by negative 136. So y is -4. Thumbs up, thumbs down. Is everybody getting that? Okay. Have I finished the problem? What do I still need to do?
X.
And how should we find x today? Back in where? The blue? Is that what I'm hearing the most of?
Yeah.
Okay, I agree with you today. Most days I would say try to go back to one of your original ones because you know there's no mistake in those, that those are correct. Maybe I made a mistake getting to this. Those are so messy though. Let's go back and substitute into the blue one. So we have 5x plus 6 times y is now -4 equals -4. Add the 24 to both sides. And everyone, what is x? So that means that our solution, we're going to write it as an ordered pair since this is a system of equations for -4. So any questions there? So we've done some work now with our rational fractional equations. Let's shift gears and try a radical equation now. So I've got this messy thing. Does anybody have an idea of how we start this one? What do you want to do?
Put the y to the other side.
Square root of y?
Yeah.
And why is that a helpful thing to do?
Because then you can square both of them.
Okay, so what we want to do is to isolate the messier square root. So in this case, we will have the square root of y minus 3 equals 2 minus root y. Change sides, change signs, subtract root y from both sides, so we have that. And then I heard that that would be helpful because we could then square both sides. Which is very nice on the left side. Square cancels out the square root, and we have y minus 3. The right side, though, you have to be careful. It is not 4 minus y when you square that. We must FOIL that out. So we are looking at 2 minus root y times 2 minus root y, which gives us 2 times 2 is 4. Minus 2 root y minus another 2 root y is minus 4 root y. Minus minus is plus. Root y is regular y. Does that look all right to everybody? Any questions on that part? What do you want us to do now? What would be a helpful thing to do at this point? What's going to be helpful here? What do you want to do?
Cancel the y's and bring the 4 to -3.
So in other words, let's just kind of try to clean it up. And we can cancel the y's because they're both positive. So if we subtract y from both sides, they both go away. And -3 and 4 are like terms, so let's get those together. So we have -7 equals -4 root y. Now what? Other people have a chance to think for a minute. What can we do now? What should we do now? Let's wait just a moment before we square both sides, make it a little bit easier. What do you want to do?
Get the y by itself.
So let's isolate that root y again. So if we divide both sides by -4, we have that root y is 7/4, and then let's square both sides again. So if we do that, we have that y is 49/16. But we are not finished. Does anybody remember what we have to do when we are solving radical equations? That's if we're taking square roots. But because of that, we can get some false solutions. So what do we have to do? We have to check it. And you cannot just check this one anywhere you like. With these, we must check in the original printed equation. So on a problem set, that means an original equation in the book, not the first line you might write down on your homework. Many of you do. Your first step is mental math and write down something a little bit different than what was in the book. That's fine, but you've got to go back to the book when you check it. So we're going to plug 49/16 in our original equation up here. So we will have square root of 49/16 minus 3 plus the square root of 49/16. And we want to know, does that equal 2? Because that was our original equation. So 3 is 48/16. So we are looking at the square root of 1/16 plus this square root will be square root of 49 is 7, square root of 16 is 4. Square root of 1/16 is, everyone? 1/4. What's a fourth plus 7/4? And what is 8/4? So 2 equals 2. It does check. 49/16 is our solution. Questions with that? Okay, for this one, now we do have a solution, a system, 3 equations and 3 unknowns. So what I want you to do is to come up with strategies. How are you going to start this? I want you to work with your partner on this, figure out your strategies, start writing things down. I will pause you before you finish getting all the way to the end so we can compare strategies. Some teams may decide to switch strategies. So start working on how would you solve this particular system. It has gotten a bit quieter, so I want you to stop writing for a moment and tell me some of the strategies you're coming up with that you're using, and then we'll finish solving it in your team. So what are you doing? So that gives you two equations with, so then you have a system, two equations with y and z to solve. Okay, that's one strategy that works. Which teams did a different strategy? What else are we trying here?
The first thing I did is line up and then
So that you eliminated the z's. So then you have two equations with x and y. And then you can solve that system. Anybody doing anything different? Or you could take either of those, that gives you one equation with x and y when you do that, to put with this one, to then have the system with two equations with x and y. Anybody do something different? I did have some people in fourth period that said if you multiply the top one by -3 and the top one by -2, you eliminate the x's and y's, solve for z. But then you still have to go back to solving a system with x and y after that. So everybody have a strategy you want to use, what you started with, or switch, whatever you choose with your teams. Let's finish working on it. Let's come up with the solutions. Right, since most of you have finished, what did you get for x? Y? Z? And do those all three work if you plug them into the equations?
Yes.
Any questions about that one? Okay, then as you begin your new problem set, let's start with number 11. This system is a little bit different. We have three equations. Every equation has two variables, but they all have different combinations of two variables. The top one has x and y, the next one x and z, the last one y and z. So let's just come up with a strategy of what you want to do with this. So how should we go about this one? What do you want to do on this one? Yeah, and I'm still not going to have anything that's really going to match up real nicely for me. I can do that. I can line them up, put the zeros in for placeholders. But what's going to be a strategy that might be the most helpful for starting this? What do you think?
Solve for x, so x.
In which one?
The second one.
Second equation, isolate it since it's a 1x.
Solve for x.
So x equals 2z minus 3, and then what do you want to do with that?
Substitute into that one.
How does that help? Because I can't substitute it in down here. If I do that, I will have 2z minus 3 plus 3y, so I will have an equation with z and y. And then I can put that with the third equation to have a system of two equations with y and z. Does that work?
Yes.
Question? You can, but it's kind of hard on this one because you don't have two equations with the same two variables, and it's going to be longer to do it that way because you have to take two of them and eliminate something, the other two eliminate the same thing, and it's just going to be more steps. This is the fastest, most efficient way to do that.